So if you see now, so far what we have done is, like, I have 6 departments, and we did subnetting. The mask was same for all the departments. Subnet mask was a fixed length. If it is slash 11 for department 1 also slash 11, 2 also slash 11, 3 also. You understand what I'm saying? But in the real world, the fixed length subnet mask is not optimal. It is not that good. What we need is variable length subnet mask, VLSM. Yes. Yeah, all the network bits need to be on. That is why for last network you need to put 255 here. Is that clear? All right, now let's move on to this. Are you ready for the new topic? Okay. So far, for all the departments, we have same mask. We have same mask. For all departments, we have same mask. We call it as fixed length subnet mask. But in the real world, each department will be of different size. See, we have a department with 300 employees. We have another department with, let's say, only 20 employees. HR group is very small. And we got another department, let's say, with only like 30 people in the department. Now, to connect all these networks, I need a router. So we connect using a router. And now, okay, let me make it a little bit more bigger. So we got another router. Right? If you see here, between router 1 and router 2, you need only 2 IP addresses. One for this one, another for this one. First one, last one. Only 2 IP addresses. Here also you need only 2 IP addresses for the connectivity between R1, R3 and R2. And here you need 300 IP address, 20 IP address only, 30 IP address. Now, if you do subnetting according to 300 IP address, you can provide enough of IP address to this, but only 20 you will be able to use. Remaining 280 IP address will be wasted. Here 270 IP address will be wasted. Here 298 IP address will be wasted. Here again 298 address will be wasted. Do you understand what I'm saying? Yes. So we cannot do subnetting based on this big number because we are wasting a lot of IP address. So if I do subnetting based on a small number like 30, I may be providing enough of IP address here, but I cannot provide here. 270 computers will be without an IP address. So what is the solution? VLSM. We need to do separate subnetting. That's all VLSM. We are not learning something new today. You are going to do subnetting separately depending on the need, where the question is going to be same. 10 is the network. This is the question. 10 is the network. We need to do subnetting as per the requirement. First question is this. 10 network, 2 IP address needed. Second, 10 network, 20 IP address needed. 10 network, 30 IP address needed. 10 network, 300 IP address needed. This is well known, no? You know it, no? You know how to do this. So if you will do this subnetting, I'll help you to fill all these gaps. First, I want you to copy this question. Copy the diagram first. So here I'm going to give the first subnet when IP address is 2 per subnet, which is 10.0.0.0. What is the slash? What is the CIDR notation? No. After subnetting, what is the mask? Why 22? You need only 2 IP address, no? For 2 IP address, how many bits you need in the last update? Just 3 bits. Yeah, only 2 bits. So what will be the mask? Oh, what happened to you? You just said last octet, and now you are saying 10. See, Kiran, this is the last octet, right? Here you want only 2 bits. All the remaining you are giving for what? Answer. Networking. So how many bits are for networking? It is /30. Okay. When it is /30, what is the first IP? Okay, I give 10.0.0.1 here. What is the broadcast? Very good. What is the last IP? You see, the first IP is 1, last IP is 2. Do we waste any IP address here? No, that is why VLSM is needed. Now, first subnet is over. Use the second subnet here. Second subnet is 10.0.0.4/30, right? What will be the first IP? .5. What will be the last IP? .6. Right? Okay, in 10 network, we are finished using from 10.0.0.1 to 10.0.0.6. We should not use these addresses anywhere else. Okay, now let us go to this one. In the 20 subnet, the 20 host subnet, what is the first network? 10.0.0.0. What is the slash? 27 is the right answer. So, but I cannot use the subnet. You know why? The first IP address of the subnetting is already in use. Yes or no? So we need to go to the second subnet. 10.0.0. What? 32/27. 10.0.0.64/27. It goes on like that. Now, let us give this subnet to this one, like 10.0.0.33 is the first IP, and last IP will be 10.0.0.62. All right. So we have finished using up to 63. 63 is a broadcast. So up to 63 address we have finished using. Now let us go to the next one. When 30 is the number of hosts, what is the mask? Same mask. Same 27. But we have used already this 32. Now we need to use this one. What will be the first IP? 10.0.0.65. The last will be 10.0.0.90. 94. Very good. So what is the network? 10.0.0.64 slash 24 27 slash 27. See, the mask is size is differing. Here 27, here 30. That is why it is called as what? Variable and subnet mask. We do subnetting as per the requirement. We don't want to waste many IPs. Now, based on 300, what is the first subnet? 10.0.0.0 slash 24, correct? What is? No, I'm wrong. No, 23. Very correct. 23. So what will be the next network? 10.0.2.0. You agree or not? Now we can use this entire subnet for this one. 10.0.2.1, 10.0.3.254 is the last answer. Correct? Because the next network will be 4.0. So the mask for this is 23. The mask for this is 27. The mask for this is 27. The mask for this is 30 and 30. When you do like this, you don't waste IP address. We call this as VLSM. Are you comfortable? All right. I'm going to give you one homework now. Are you ready for the homework? So this is what the question is, R1, R2, R3. And this is going to be 172.16.0.0 network. Will you do this? All right. Take this as a homework. And tomorrow we are starting with routing.